platform for really engaging with the community, with thought leaders, and really kind of help kind of foster thought leadership around entrepreneurship, around AI, around data. And so we do a lot of events. Some of you were probably here last week at GE Ventures. We did one on IoT and blockchain. And so we've touched close to 10,000 people. And so those are some of the events we have done in the past. We do this with the help of sponsors and partners, and I'd like to especially thank SAP for sponsoring the Hive think tank. And if you're interested in being a sponsor, reach out to me. Before I get to kind of the speakers, I'll just tell you a little bit about the Hive. The Hive is an investment entity focused on the very early stage, so we collaborate with entrepreneurs to create companies, all of them focused around data and data-related techniques like machine learning, deep learning, natural language processing, computer vision, and so forth. And so we are very thematic, and so we pursue applications and use cases in the enterprise and a few key vertical segments. One of the main ones is the industrial segment. And so you can see some of our companies out there between the Hive India and the Hive US. So Foghorn, Sensify, we have a company, Urego, that's been acquired by GE from the US, and Altasom and Flutura from the Hive in India. So with that, I'd like to tell you a little bit about the panel today. And what we'll do is I'm going to introduce the speaker from SAP, and subsequent to that, we'll get kind of panel here. We'll have about an hour of discussion, and there'll be ample time for Q&A. So if you can save your questions for that end. So Yaad Oren is the VP of Corporate Strategy at SAP, and he's responsible for technology and platform. And he's also a lead technical advisor for SAP.io. And he's going to give us a brief overview of SAP's strategy in the IoT meets AI space. Yeah?
We have a clicker for the slides.
Cool. Thank you, Ravi. And hello, everyone. Welcome to SAP Palo Alto. My name is Yaad Oren, and I lead corporate strategy for platform and technology. And Ravi, thank you so much for doing this great job. Either you're doing a great job and the event's getting bigger and bigger, or we're just serving better and better alcohol. But it's very fun for me to be here again, speaking again in the Hive. And as Ravi said, I'm also the lead technical advisor for SAP.io, and I would like to say a few words about SAP.io before I present to you in a nutshell about what SAP is doing in AI in IoT. And so SAP.io is the business unit in SAP which is responsible to building the next generation of ecosystem of startups that build the next generation of enterprise solution. We are investing in startups globally, and we also have foundries around the world where we help around 50 startups at the moment, accelerated, and to build very innovative solutions using machine learning, IoT, to bring the best that we can to our customers. So this is in a nutshell about SAP.io, which I'm a proud member of. A short disclaimer before we are starting. Yeah, and before we start deep dive into AI and IoT, I would like to give you a really short overview about SAP strategy. And as you probably know, SAP is the leading vendor for enterprise application. We're doing this for over 4 decades, and we have a huge responsibility for our customers. We passed the 350,000 customer bar recently to help them strive in what we call the digital transformation. Now, I know most of you already are familiar with digital transformation. You came here to hear about AI and IoT, but really as a one-liner, digital transformation means that we are seeing a proliferation of technologies that really helping customers to innovate better. We are seeing technologies as machine learning, IoT, blockchain, big data, and cybersecurity. And customers really would like to know how they can harness these advanced technologies and really innovate better and thrive in what we call this digital era. So So I'm not going to deep dive too much into what SAP offers in each dimension, but we are offering solutions around 30 lines of business, 25 industries that help customers to run their business in the best way they can and also innovate in the best. But I would like to put a spotlight on one of the strategic products that we recently launched in Sapphire in May, and this is SAP Leonardo. SAP Leonardo is what we are calling the digital innovation system. It's a combination of two parts. A set of solutions and technologies around all those cool and services around all those cool unique technologies, machine learning, big data, blockchain, and so forth that customers would really like to harness to their business and show growth, together with the human factor when we are offering consulting services for ideation, helping our customers to think, hey, what you can do with AI, what you can do with IoT, and really provide the design thinking, even help with prototyping that help them to reach this goal. So Leonardo is a huge framework of those two components, and together we are helping customers to really innovate better. And after usually 6 weeks of time frame, they are starting to see business results. So putting another spotlight on what SAP offers in IoT, we have a huge organization, develop many solutions. I'm not going to deep dive on any angle for the sake of time, but if I want to focus on the three main things we are doing in IoT, first of all, we are offering a portfolio of applications with out-of-the-box value for our customer, solution like connected products that literally can connect all the products in enterprises, from customers who are connecting their construction equipment and monitor them in real time, all the way to get customers who are running a vendor machine and replenish them, a vending machine replenish them using IoT. Also a solution like connected fleets that help to solve the very complex problem of optimizing the fleet of trucks and supply chain management solution. So this is the application part that we are offering for our customers, but also we have the IoT Foundation. This is a platform that has technical services that customers can develop their own solution, but also very interestingly, it helps to connect the IoT world into the core enterprise ERP system, the IT system. SAP, one of the main values we are bringing in the IoT and machine learning game, that we know also how to connect those rivers into the oceans of ERP system that we are providing. So this is the foundation, and last but not least, one of the biggest trends at the moment in IoT is the edge computing, helping to move the computation from cloud to the device. SAP also offers there as part of Leonardo a set of services that help to do persistence of the device, lifecycle management, machine learning, and this is help us to help our customer to strive this new reality when the landscape is cloud and edge together. Before we are talking about what machine learning can do with IoT, let's have a short introduction of what SAP is doing in machine learning. And really, I cannot stress enough how important this field is to SAP. SAP is a very strategic goal to create a system of intelligence. We believe that the ERP world is coming from system of records, system of engagement, to system of intelligence, where we are leveraging machine learning and artificial intelligence in really augmenting human work, help automate the process. And our goal there is to provide intelligence enterprise applications where you can do many scenarios as matching payments in finance use case and help to open the bottleneck where you need to reconcile payment, all the way to services that help to scan a resume and automate the recruiter work. And we also offer technical services where customers can build their own solution, bring their own data, training models, using NLP, machine vision, speech recognition, and pretty much differentiate and create new solutions. So, of course, IoT and machine learning are two big stars of their own, but just like the Golden State Warriors, when you bring Kevin Durant and Steph Curry to play together, this is where you get the real synergy, right? So when you combine machine learning and IoT, it brings us the possibility to really adopt what we call a proactive approach, okay? You can connect devices today with IoT and you can get real-time information, but without machine learning, your prediction capabilities are relatively limited. You have what we call post-mortem view of thing or real-time view of thing, but together with the machine learning, we can really look ahead and predict better what will be the outcome of a plant or failures in equipment and so forth. So this opens us, this approach of having proactive decision making and really, and then in machine learning and IoT open an ocean of opportunity around what use cases we can do. And I will show in a moment, I will end up with a customer example about our customer utilizing this, but without deep dive too much into what you can do with it. Like I mentioned, the forecasting is a big thing, but also anomaly detection and failure prediction is a huge, huge thing, where together with IoT and smart machine learning, you can really understand when something is going to break. But for our customers is very, very important. And for me, the most definite things you can do is around identifying new relationship correlation. Think again about SAP, as I mentioned, is very proud to connect IoT and machine learning to the core of the ERP. So we can understand with machine learning, for example, how two sensors breaking down is translated into warranty claim, and how potentially this warranty claim is related to a performance of an employee in the HR system, and so forth. So really increasing the reach of the machine learning clusters and classifier beyond the IoT into the holistic view of the organization. Let's have one example, one key example where of the application that SAP provides offer machine learning and IoT together. This is around predictive maintenance services. It's making this slide a little bit more happier and simpler. Let's say that Ravi is the owner of an oil company, and I'm the manufacturer of, I'm selling equipment, drillers and construction that help oil companies to build the rigs and maintain them. So before the IoT and machine learning, every time you have some maintenance request or some failure, you are calling, Ravi is calling me and say, hey, my driller bros, can you bring me a service agent that can help me repair this? This usually takes a lot of time. Ravi is losing business, it's becoming unhappy customers. My technician can come with the wrong data or the wrong service or the wrong parts because it doesn't have all the data that he needs. And this usually takes a lot of time and big business problem for our customers. With SAP Predictive Maintenance and Service, I am, as the manufacturer of those drillers and equipment, know in real time what's going on and how Ravi utilizes those assets. I can know using machine learning when predicting a very high accuracy when those drillers or equipment will fail. And by this, I can start rolling out my support agent, my service agent, that she or he can provide Ravi the resolution before time. And this solves a huge business problem for our customers. This is billions and billions of dollars of customers problems we are solving. And to end up with one example, you are more than welcome to go to a Leonardo website, or in this case, SAP Predictive Maintenance website, and see customer testimonial. I chose to show an example from Train Italy, which is the leading trail operator in Italy, not only because I like trains, but really when it comes to trains and train components, all the business. This is really hardcore IoT, right? So they are transporting over 2 million of passengers per day. And trains travel hundreds of millions of kilometers per day in Europe and have thousands of trains, locomotives, and so forth for cargo and passenger. Their maintenance cost is measured in billions of euros, which is huge, right? Because all of us it's pretty easy to imagine how much maintenance trains need. They're implementing SAP predictive maintenance, and they're projecting saving costs in hundreds of millions of euros per year, which is a lot. And you can see some of the image from the testimonial. You're more than welcome to hear more customer examples, like from the CEO from Italy, about how they utilize the solution from SAP, like predictive maintenance, leverage IoT, and machine learning. And for us, this is a great business outcome that shows the value of combining those two technologies together. So that's it from my side. I would like to thank you again for coming. And if you have any questions about SAP, AI, and IoT, feel free to reach me directly, or just go to the Leonardo website, join the panel, and rather thank you again.
Thank you, Ian. With that, I'd like to invite Grant and the rest of the panel.
Member of the Dream Team mic'd up. Ravi, you can take it from here?
Yeah.
Okay. You said this was the Dream Team. I think I couldn't dream of a representation of older companies on a panel, given this is Silicon Valley. Who's older? Is it Siemens?
I think so. 170 years. Who can beat that?
It's a senior tour.
Yeah.
So maybe we start with one of the younger companies at the end, and we can just go down and everyone introduce themselves quickly.
Yeah, sure. Cisco, we're only 30 years old.
Yep.
But we have been investing for about 20 years now. We started investing in the mid-1990s. You know, on average, we invest about 20 companies a year. You know, so we've active portfolio over the last decade, we've invested in about 200 companies. You know, those we've had about 32 that have been acquired and 13 or so that have gone public. The way to think about you know, the activity in our group is, so I lead the teams responsible for IoT. In addition to that, the activity around enterprise networking, our collaboration business, and then the activity in digital as well.
Yeah, so I'm Debjit Mukerji from Next47. Next47 is the recently reimagined and recast venture effort by Siemens. So we are effectively a brand new venture capital firm with primarily financial objectives with a sole LP structure with Siemens. We have a $1.2 billion fund, which we're just starting to deploy. And we are very much independent and autonomous by design. The goal is to be able to anticipate huge market forces which can impact both Siemens businesses as well as our customers will in the future. And we invest really in very broad categories, and we have a lot of latitude in determining what's exciting for us. So if we can make some kind of a rational connection that Siemens could reasonably be a part of a given market in the future, then we can make a good case for investing. Given the fund size, our typical bite size is anywhere from 3 up to $15, $20 million in a single check. We're going to do about, when we get going, probably about 15, 20 investments a year. And we have 40 people around the globe. Palo Alto is one of our biggest offices, but we're in Boston, Munich, opened up an office in London, have presence in China. So we're truly global, and we have full access to. We're kind of the best of both worlds. We're a financial VC, effectively, in terms of speed and autonomy, but we have full access to the global resources that Siemens can provide to add value to the portfolio.
Hi everyone. My name is Abhishek Shukla, and I represent GE Ventures. It's glad to see some of you. I saw some of you last week in our office for the Hive blockchain event. So, GE Ventures is the venture capital arm of GE. We invest across the business areas as it is relevant to GE, including healthcare, oil and gas, power, software infrastructure, which is my expertise. I look at investing across cybersecurity, cloud infrastructure, and industrial IoT. GE Ventures is actually not that old as the parent company. GE Ventures was just started in 2013. Since then, we've been deploying at a rate of about $300 million a year. Typically, looking at Series B onwards, typical check size of $3 to $5 million. If there anything interesting, I would love to talk to you afterwards. Thank you.
Thanks, Abhishek. I don't think this works. Just not what it's somewhere.
There you go.
All right. Vijay Reddy from Intel Apple. We've been investing since 1991. Around $4 billion today. 1,500 portfolio companies. Typically, we invest $350 to $500 million a year, which makes us one of the top 3 venture firms here. We're stage agnostic, all the way from $100,000 to $700 million, so buy side range. We're across the globe, many countries. And the way we look at it is we only invest in companies where we can add value. We don't need business name approval for doing deals, but we tend to see where Intel can add value now or in the future, and then tend to find those companies and invest. Pretty broad portfolio, pretty broad areas of focus, all the way from drones and wearables to enterprise IoT and flying cars to everything else. Anything which needs compute, we tend to look at them. On the IoT and AI side, we've invested more than $1 billion at AI itself, looking at IoT and discussion of AI, blockchain, and as well.
Okay, well, you get the award for having invested the most in the space we're going to talk about tonight. So I'll kick off the conversation with you. What is IoT, and how much intelligence do you need to have in IoT to realize this full potential that we've been hearing about for from SAP about connecting all these different sensors, driving it all to major ERP systems, and changing the world.
So from an
It's a bold vision.
I think I'd like a long-winded answer, but from an Intel standpoint, we look at IoT and AI in 3 phases, right? The first phase was sensification, where you add sensors to the devices and you try to connect the pipes to the cloud. The second was trying to add more smartness to it, which was trying to find where the compute used to happen, which was primarily in the cloud and in on-prem servers, and try to move data towards that. And the third phase is what we call autonomous phase, where we're trying to move the compute towards where the data is. And we're looking at different ways by which we can add AI, either in the cloud, either on the infrastructure, or on the edge itself. And so we're kind of very excited about how we can help companies like Siemens and GE and others in their journey towards moving more intelligence towards the edge itself.
And so are you positioning that we have to move to that third phase for us to really unlock the value potential of IoT?
No, I think there's...
Or is it going to be a world where we see different sectors or different applications ultimately end up in different phases?
Yeah, so we're big fans of anywhere there's compute, it's fine, because intelligence can move towards the cloud. I mean, if you look at deep learning, it's training on the cloud and trying to implement the inference at the edge. But compute can happen anywhere, so I think the whole fog architecture and the fog computing comes into play. So anywhere it makes sense from an architecture standpoint, because each application is different, we think it's a place.
So how does GE think about pushing that intelligence to the edge, and or do you have the dividing line, and how much intelligence do you need to actually push out?
Great question. So I think to start with the first question that you asked, when I think about IoT, actually let's leave the word itself for a second. What are we really trying to achieve? What we are trying to do is achieve a particular business outcome, and which might be improving the efficiency, increasing the bottom line for a company or utility, so on and so forth. But if you're trying to do that, in order to do so, you need to complete X, Y, and Z steps, which might be, as Vijay pointed out, connecting the stuff, getting the data, and piping it to the cloud or analyzing it at the edge. When I look at it, we are investing it from a perspective of what the overall business outcome we're trying to drive, because that determines how much compute you need to have at what place. It also determines what kind of models can you run at what place, and then eventually guide it through the process. To give you an example, we are looking at companies which are doing one of the companies which we just started, like Avitas, looks at multiple kinds of computer vision, multiple kinds of data. A lot of that is processed at the edge. The analytics models are also running at the edge, because you can't have a huge pipe to the cloud all the time. So at that time, you need the compute and the models to be running at the edge to make some inference and then send it over eventually to the cloud. So I would say it all, eventually for us, it's the final outcome, and we design the process accordingly.
So I'm curious, we mentioned drones. That's obviously a place where bandwidth is fairly intermittent and tough to grab it. I agree, but what are some of the areas where we probably didn't see that problem that GE is thinking through? Are there applications where you're simply just pumping huge chunks of data to Predix and have a Predix machine kicking?
Yeah, there certainly are, especially if you think about the big hot spinning things which we have, multi-million-dollar power turbine, gas turbines. The compute is not a problem. You can, and the pipe back to the backhaul is not a problem. Yes, that's fine. But if you take the same turbine and you put it on a jet engine, well, connectivity is not almost always guaranteed. So you need to decide on the scenarios when some of that intelligence is at the edge. I think in the world as we move forward, it's going to be a compute as Vijay was saying, will move from one end to the other irrespective of depending upon what outcome you're really trying to drive. I keep coming back to that. Sorry.
So how does Siemens think through this dilemma with MindSphere and what X47 is trying to accelerate, I guess, within that group?
Yeah, I think with MindSphere, there's a bold vision. the first step, I think it actually follows Vijay's paradigm pretty well. The first step is to connect all of the machines that we have and send them up to the MindSphere cloud, where customers can use a variety of applications and analytics to mine that data and drive intelligence and get to real business outcomes. There is, though, very strongly a dimension of this where we push intelligence down to the edge. And by the edge, typically we're talking about gateway level, PLCs, and something with reasonable horsepower in terms of processing capability. But things are getting so much more efficient locally that it makes sense to deploy a lot at the edge. And why would you deploy at the edge? Typically 4 reasons. One is you need to make real-time decisions, so low latency situations. 2 is limited and broken connectivity, which you touched on. Another is bandwidth problems. So if you're spending too much money sending bits up, and it's a very compute-intensive problem, that can be an issue. And the 4th is security. So if you need to do something locally and you don't want to send the information anywhere, those are typically situations where edge compute matters. And we are seeing, I think, increasing need for edge compute, just given, I think, what I would call the responsibility of machines elevating, whether it's robots or drones, machines that are operating around humans. We're seeing kind of this elevation of need for edge computing. I think when I think about just the broader vision for IoT, for me personally, it's really about democratization. So it's about devices today having sensing capabilities, processing, memory, and comms at a much cheaper cost than ever before. We've had machines for decades that have operated with SCADA systems, traditional SCADA systems, and working on fairly complex and sophisticated algorithms. But IoT is really about the vision of heterogeneity and about volume. It's about bringing sensing capability and monitoring everywhere. And I think that is really where it's really about the cost coming down and making it economical to be able to kind of add additional dimension to our intelligence.
And you're starting to touch on an issue that we talked about earlier. Do you do some of this processing on the device, or gateway level, or there's some hybrid? So CISCO knows a few things about gateways.
Yeah.
You can chime in about where you see some of this intelligence residing, but also more specifically, what does intelligence mean to CISCO? You mentioned security and some of the other things, but I'd like to get more specific.
Yeah, so we really pivot IoT around our Jasper business, which is a company we acquired a couple of years ago that really manages connectivity between the cloud and these edge devices. So when we think about that, the areas that are interesting to us are what are the next generation high volume, high unit volume, high data volume endpoints. So we spend time around the drone ecosystem, the autonomous and connected vehicle ecosystem. We're looking at things in ag tech. And I think in those markets where those devices have to be intelligent, you are going to need some computing at the edge and the ability to recognize objects at the edge. The amount of data you might have to ship back or the need to make a decision in real time is going to force you to have some type of compute element at the edge. That isn't to say that bringing data back and having a centralized repository of data or metadata doesn't provide value on top of that, but I do think you will need some intelligence at the edge. Other areas that are of interest to us, we're deep in the security market, so making sure that as you connect these additional devices, they are secure and protected is also an area where we spend a fair amount of time in the IoT security space. And then I think as most people recognize, we think a lot of the value is going to be in the data that's captured here and the ability to either through AI or simpler forms of data processing applies to intelligence. So that's sort of the other area that we spend time.
Okay, so we're hearing more about AI, machine learning. What are some of the things that you would look for an AI agent to do on one of these devices, or either the collector or gateway level, or even on device?
Yeah, so on the device, I think it's image recognition, right? So using deep neural networks to recognize types of objects, maybe even to in cases where you don't want to, can't or don't want to send the image all the way up to the cloud. You may have to just abstract the model of that image and send that up to further iterate on the model and push that model back down. So I think in those kind of cases where as Debjit said it well, where there's connectivity, real-time need, or privacy or security concerns, I think are areas where you do that. There's certainly applications, though, where having that macro view of all the data, and that's where the network effects of some of these businesses really take place and take hold, is super valuable. So I think to the extent you can centralize, you probably do want to centralize. It's probably cheaper compute. You can get more scale out of it, and the network effects around bringing that data together has benefits. But there will be decisions that have to be pushed out either to the edge or actually on device. And so I think we're recognize that.
Is there a universal view that we're going to have to significantly increase compute capabilities of these edge devices to handle things like image recognition, to deploy a CNN, to get into some deep things for perception and what a robot might want to understand in the next thinking application? Because it's certainly Intel is looking to sell that.
That's the dream.
No, I think
It's
it's
a
about,
softball tip for you.
no, I think that it doesn't matter to us, right? Because if the processing happens at the edge or it goes to the cloud, we play in both spaces. So it's kind of almost inevitable for us. But I think having seen the use cases which have come out, there are more and more bullish that, especially in the vision space, we need to have more intelligence towards the edge. For example, we used to have neural nets which were like 3-layer cake, hundreds of layers cake. And if you need to recognize really complex objects, not just a dot, you need like a terrier and others. So as complexity increases, the value for data and the ROI for getting more analytics increases. It's a pretty no-brainer that you need to push as much compute, not just on the edge but on the cloud as well.
So is it those vision applications that excite Intel the most?
No, I think
drones and robots, or are there other things that get you all jazzed in terms of just really maximizing the semiconductor capabilities that you all need?
Yeah, so on the processing side, I think vision is definitely has shown that neural nets with the CNN or anything else, right? It's really good. I think robotics is a great place, as you've seen, where reinforcement learning and deep reinforcement learning. Again, it's primarily driven by cameras, but even on the audio side, I mean, you're using neural nets there too, right? So audio applications, whether it's Alexa or smart home, and last but not least is NLP too. Right? I mean, NLP needs deep compute. So all of those are good areas.
Your friends to all.
Your friends to all. So we're like the Switzerland of compute. So.
I guess just to add to that, the perspective, for example, in the industry, and you know this, Brian, very well, is the first step of doing anything is get that physical asset or physical data converted into a digital one, and then make sense of it. Because a lot of the typical deep learning problems or the typical AI problems relate to the data which anyway was digitized, shopping history, so on and so forth. In this case, the first step is to convert that physical sensor data into this. And it can be the SCADA data, it can be whatever kind of ICS data. And I think there is a lot of method to the madness of first identifying, okay, is this a heat pump? Which kind of heat pump is it? And is this, is it the same thing which I tagged last week? So a lot of tagging, so when you think about AI at the edge, for us it's a lot of the things back to basics, which is okay, before you can do all the magic with all the cleans data and run your fantastic model, can you do the basics and at least clean that data up? That's where a lot of AI models are working for us too.
And I will tell you, as we deepen the discussion, I'm going to keep a running list of where entrepreneurs and other partners and other players can actually play. Because if we stipulate to all the big guys doing everything, and, at the edge and in the cloud, where are the pockets of value? Where should investors be putting their money, and where should entrepreneurs be spending their time? So already kind of touched on an issue, which is analog to digital, signal processing, setting up the data, taking time series data, doing some automated tagging, and prepping it to realize this data tsunami that's coming into the system and how to make sense of it, to actually extract value and realize it's IoT potential.
Absolutely.
One area that we're super excited about, just because it's so technically challenging, is autonomous driving. So we talk about computer vision, and we've certainly done a lot of vision applications, both with robotics broadly and also drones. With autonomous driving, it's not just vision, but you've got RGB, LiDAR, radar, GPS. All of these inputs have to be fused, and they all have to be contextualized. And I think the sheer processing needed to make sense of the world around us. And for such a difficult application like driving, which is obviously real time, and you've got to effectively process tens of gigabytes per second of information at a time. It's one of the most exciting and technically complex problems. And I I think Next 47 is really excited about problems that are really hard, because the harder the problem, the more distance between the very, very best companies and the ones that are not so good. And we want to invest in the very best.
Okay. Well, I don't want to get too geeked out in technicalities, but we think about the same thing with robots, and there's kind of the sensor fusion, understanding what's going on, bringing in all those different pieces of data, and just understanding pose, position, and context.
Right.
And then there's the second piece, which is really taking that and deciding to do something, and understanding a path, planning that path, optimizing that, which would be telling the car to brake or turn or keep course at 70 miles an hour, even as you have all these exogenous things and bikers that come out in front of it and so forth. And then there's the even, in my mind, hairier issue of how do you deal with those external variables, communicate with other cars, do fleeting, swimming, and then also real-time reaction. So in terms of the IoT intelligence issue, where do you all rank order those things? Is it cascading complexity and therefore value, or would you say that you want to just first start with the sensor fusion and try and make sense of that, and that's just what we have to do first?
That's probably what you have to do first. I think the sensor fusion is first, and it's really about perception and interpretation of what we're seeing. And then the part about the decision making is extremely, extremely hard. And in driving in particular, it's a really complex issue, because I think a lot of regulation that comes out, there's going to have to be accountability. And there are a lot of startups that are approaching the problem for decision making using pure AI techniques, which are effectively black box, and you can't retrace how a machine made a decision. That's going to be really, really tricky. So I think it's going to be really interesting. We're going to have probably a complex blend of deterministic models that are rule-based, as well as a ton of learning that goes on. One of the most interesting things is that if you think about it, I'm assuming most of you learned how to drive in the US. Most of us knew how to drive before we sat behind the wheel of the car. We learned. It was already programmed. And we had to go through the steps, and we learned a little bit. Of course, we refined our models. But it's amazing what the human brain can do, and we're effectively trying to do a lot of that with machines. And so for me, that's one of the most exciting spaces.
Interesting. What other machines, in terms of imbuing them with intelligence, do you think we should be looking at to put money behind and connect, other than cars?
Yeah, I think robotics is certainly another area. I think you mentioned it's probably a little closer to your space than to ours. But I do think that that capability can really gather a lot of benefit for the manufacturing industry, just in terms of throughput and consistency, bringing best practices to a certain level across factories. So I think that's a very, very hard problem to solve. So I think that would be one where you see a lot of innovation. I think the reason the autonomous vehicle industry is so interesting is because it's probably one of the largest shifts in the American economy in the last 10 years. Mm-hmm. And when markets like that happen, they tend to get a lot of R&D dollars, and there's a lot of innovation, a lot of R&D dollars going into that market right now.
Okay. So it's a pretty seismic shift, therefore uncovering opportunity. There's some other areas that have traditionally been mentioned in the same breath as IoT, such as consumer wearables, smart buildings, smart home, interacting with your home with voice, Nest thermostat right around the corner. It's one of the classic IoT exit cases that's generated a lot of value. Are there more of those? Or are there more of these benign IoT connected thing opportunities out there? Or should we all be looking at these exotic next generation flying cars, flying drones, kind of things?
Yeah, look, I think the consumer space, it's not an area where we spend a lot of time, so I can't opine on that very well as a user. I do think there will be some interesting consumer connected devices. I think that tends to be more of a hipster in business because people aren't necessarily buying for the value necessarily that they get; they're buying for multiple reasons. And I think it favors a lot of times the larger brands that have mind share with consumers already. So I think you have to, if you're starting to maybe a little bit of a handicap there. I think
if you're trying to create your own brand.
Yeah, if you're trying to, if you're not making an element of that. I guess you could say there are some next generation silicon companies that are trying to do silicon at the edge that is focused on running some of these algorithms in a more power efficient manner, should they get designed once it's some very large, high running consumer devices, that would be an interesting area. It's not an area where we personally spend time or where Cisco spends time. So I think that's one. I think companies running, taking some of the more complex algorithms and figuring out how to fit those into smaller software footprints and enable less sophisticated companies to come to market with products like consumer enable or B2B type of products. I think that's also potentially an interesting area.
I think just to add to that, in consumer and then obviously also in the enterprise world, I think the winners versus the losers will be determined not by how cool my algorithm is, but what kind of data do I have access to? And is it only me? Can I do this? Or is it, can I do some magic on my data? How exclusive that data is? In enterprise world, we see this. Machine learning models have been around for a long time. We've been using that in GE for a long time. But really, the typical machine learning tool bench versus people who really have their own domain expertise and then add that flavor into that is the differentiator. The reason why Nest became really successful was not probably just because they could connect to the Wi-Fi and connect to your thermostat, but because they could identify what your needs were with that model. Plus, Google gave them, or whatever, Nest acquired a lot of data, which was pretty unique to them. And I think the fight will be among the companies, both large and small, with the kind of data you have, the kind of domain expertise you bring in before you talk about any algorithm and compute, which unfortunately are going to be commoditized as we're seeing.
You also bring in an interesting point where Nest was put out there as this intelligent thing. I actually hated my Nest because it was trying to make decisions for me, and I wanted to just keep me cool and comfortable. What are areas where we're going to say enough is enough, we don't need more intelligence? And this is an issue that actually comes up within ABB because we deal with industrial safety. And often we don't want our robots to be making decisions or stopping when we don't want them to stop. We put proper safety guards in place, but we want the thing to be doing the same thing over and over, variable downtime, and know exactly what they're going to do and it's going to do that.
Go ahead.
As a toss-up.
Yeah, I think my gut reaction is that we have a little ways to go before we start hitting the brakes. I think there's a lot to do in terms of additional deployment before we get there. My sense is it'll probably be on the consumer side first. One space I'm really excited about is robotics. I actually think manufacturing is one of those areas that will be transformed. It is transforming. It's following the pattern that we see in energy as well, which is decentralization and more distributed. And that creates a lot of opportunity for IoT because we're talking about fragmenting formerly centralized systems. We just invested in a company called Veo Robotics. It's actually a seed investment, and we followed up with Series A. And specifically, it's about making robots easier to manage around humans. So this is about training robots to work around humans, where robots can be very large. We're not talking about small things, but very, very big robots that are meant to do kind of heavy lift activities, but are nimble enough to respond to humans. I think we have a ways to go to determine where the boundaries are and where the limits will be. So my feeling is we haven't really approached that as much in industrial IoT. I think we have a ways to go in terms of we're just getting started. Yeah, I think we've got a long way to go to deploy more intelligence out there.
Yeah, and I think ABB, Siemens, and GE, it's unlike I can roll out the latest algorithm and ask for forgiveness if my temperature is too hot. In a deterministic environment like a factory floor or looking at the nuclear power plant or whatever that is, unfortunately zeros and ones are zeros and ones. So you can't roll out and then expect something else will not work. So unless you're really sure, absolutely confident on this is the result which I'm expecting, and to the point that machine can be assisting me, but at least for now, we want humans to be involved in this process. There will be a time when this will go away.
Another thought, and then I want to dive into that a little bit.
I don't know if the question is more around higher level cognition or is it more like just AI for sensing and stuff. The higher level cognition, I agree with them that it's crystal based off. I think Andrew said worrying about robots is like thinking about overpopulation in Mars. It might happen at some point where it's not now. But I think at the same time, we should have checks and balances, right? I think there are high value use cases where you can't just let AI do its own thing. For example, like 747 should not be like completely on the AI side. I mean, it's useful for like vision and sensing and all that stuff, but you can't let it run rules-based or policy-driven kind of decisions on its own.
About 97% of your flight
It's
is on your own.
No, I mean,
I don't want to tell you that.
the last 3% is the one which I'm scared of, right?
That's exactly right.
I mean, it might speak to a business opportunity around when you do have some of these deep learning models that the failure mode is less predictable, and maybe there's a testing opportunity for a startup there to go after the boundary conditions and understand, okay, what happens when this thing gets data it's never seen before, how do you get comfortable with that, right? So I think there will be some problems that are so complex you need that type of black box solution, yet so dangerous or so high stakes that you can't have the black swan type of event.
And even as a garbage is garbage out there, so
Yep.
it's very narrow AI. That's one thing there as well. I think there are people who are developing other kinds of AI, which I'm a little bit more worried about. But I think the existing AI, I think, fine.
That's an interesting point. Identify failure modes, and also in our cases with deploying some of these reinforcement learning techniques, we start to see some interesting behaviors on a robot that we wouldn't have otherwise programmed. It's still able to complete its task and do it fairly efficiently, but that's where you started. You want to know if it's doing some weird stuff. Is this vectoring towards something that's ultimately bad, or is it just coming with a different pathway to get
Found
to
more
the
efficient
same
way.
conclusion? Is it going to win the Go game with a different strategy altogether?
Yeah.
So when the bots
uncovering something very creative, very beneficial, but is that ultimately problematic for your closed loop control system?
I was just going to say, probably bots are implementing their own language right now, right? So,
Yeah. But that could be a very efficient language, especially for an industrial protocol. Interesting. So are we universally okay though with where AI is trending? Is this an existential threat? Or should we just keep it in the IoT context that this is about processing data and rules at the edge and not about artificial generalized intelligence?
I don't think I'm qualified to talk about it. So I was at Oxford and Cambridge a few months ago. There's a Center for Existential Research at Cambridge right now, where all they think about is how is AI going to kill humans and what are the policies that are in place. I think so. They're educating the UK government and other policy bodies about what AI can and cannot do. I'm looking at that. It still plays out. Keep an eye on it.
I think in the industrial world we are a little bit more pessimistic on just because the traditional rules of AI of having tons and tons of data and train on it doesn't apply because we don't have the failure events as much. So new algorithms, new techniques are still being devised. I don't see a judgment day coming any soon. I think it's going to be a long while, and it's going to be a symbiotic relationship. There will be some things, a lot of repetitive data, which humans are bad at with multivariate variables, or there will be a lot of different things which machines will be doing, or some decisions which can have life or death consequence today. I think they will still depend upon human rather than an algorithm. Things will change.
Completely agree. I mean, we're the #2 robotics player globally, so we tend to paint robots in a much cheerier light. But we also think more about having the AI that we're layering on top of robots actually lie outside of the control loop. And I think that's something I wanted to touch on. There's almost been a stipulation in the conversation that we're going to have almost like a river of data. And SAP would make us think that it's going to be this enormous river, which I think it will be at the time. But it's all going to some big thing, like an ERP system or to create a MindSphere or our ability system. That connotes a single flow of data that has tributaries that all kind of lead to the same thing. And at various points in that river, you're going to have intelligence, different decisions being made. But we would also like to think that there are other tributaries. You might have a closed loop, traditional SCADA DCS system, and then have an AI agent that sits on top of that to detect things. And then within the rules imbued by that control system, maybe make tweaks, changes, etc. And for robots, you might have something that sits on top of it. So VIO is a good example. You still have a traditional controller by ABB, KUKA, FANUC, and you have a LiDAR-based flash IR sensor on top of that to have a safety-rated sensor to tell the robot what to do.
Right.
But it still can't violate first principles, and still going to operate within the confines of what it can mechanically and programmatically do.
Right.
So I mean, is that, I guess, fit with your thesis, or do you think that you're going to start to see those merge?
Yeah, I think that fits with the thesis in general. I think I mostly agree with that. Yeah.
So are you guys thinking about separate intelligence that would sit on top of your traditional CISCO gear?
You know what, I think we haven't spent as much time thinking about that. I think for us, generally, the stakes are lower in the markets that we play in.
So I guess in the life and death situation, it's
Yeah.
bigger.
So, we haven't spent as much time thinking about that. I do think, as we think about data and where data goes, I do think it feels like there's an opportunity in the market. We've seen a number of companies start to look at, that is, as I have more and more data that I want to share with other parties, and this is not really, maybe it's an AI, maybe it's related to AI, not as much, but I think as you have more and more data being thrown off by the devices inside your enterprise, you'll need a clearinghouse or a brokerage that has policy around it that says, okay, this data I want to share with ABB because they're responsible for maintenance and upkeep of my equipment, or GE, but this other data I don't want to share with anybody outside the enterprise, or this I want to share with my security team. And these people here, they get access to everything because it's the super user, right? So and that doesn't really exist today. So it'll be interesting to see if SAP or other companies sort of are able to address that.
Interesting. And you think it is the SAPs of the world will be best positioned to do that, or is it going to happen within each system, whether it's Predix,
So I think there's some ground rules on that. And I was just talking to the CEO of Turbine last night, who is spending a lot of time. I think the first question we need to ask is, whose data is it? Of an IoT system, think about a light or whatever. Define the asset in the field. Is that the OEM's data? Is that the data who's everybody knows the John Deere example on what happened. So basically, John Deere, what they did was, I don't want to back them up, but basically they changed the software agreement on their $1 million farm equipment, just to say that all the data of the farm is now by any means can be used by John Deere. Nobody figured it out until the Farmer Association eventually saw that. The point is, they went to court. John Deere eventually said, it's my data. These guys said, it's my data. Nobody could figure it out. Eventually, the leasing company came up and said, you know what? It's my data. and there's a Supreme Court ruling going on. So I think until, this is a very complicated problem, until you identify the data usage, the data lineage, and basically who all has the custody. And if I change something in my model on which Vijay's model is based on, and people die.
Industrial data, because we have a lack of training data. We're not seeing that many failures.
Exactly.
To make these powerful models, we have to match it up across user instances.
Yeah, and somebody has to be the custodian, like Matt said, because if I change the data which he's going to use, his data will spit out the best answer for that particular data which is already corrupted. And if lives are lost, whose problem is it? So I don't want to put the direction in AI, but there's a fairly complicated problem. People are, I'm not even one person smart as people who are at it.
We talked a little bit about the dangers of, sorry, I didn't mean to interrupt, but we were talking earlier about the dangers of AI. I think one way to think about it is there's the inherent danger of AI, which is that machines get smarter and smarter, become self-learning and so forth. The other aspect that I think is potentially a more near-term threat is that we begin to invest machines with more and more authority, decision-making power, and they become security weaknesses. And it's easier for others to come in and find weaknesses and loopholes and actually corrupt the system. So it's not so much AI-driven machines doing the wrong thing, but perhaps being taken over by these forces.
So what are some of the ways that Siemens is trying to unpack that and give us a black box, trying to make sure that we can invest in those security holes?
I think it's a really, really hard problem. It's an area that we're spending a lot of time on. My team is. It is not easy. I think industrial networks in general are not that well fortified, and I think there's a certain level of sophistication in IT security that hasn't quite made it over to OT. And we're trying to figure out how to bring the best of IT to OT. And I don't think we really have cracked the code. We are trying a few different things, and startups are leading the way there, but we haven't figured it out. I think we're early in the process.
Yeah, I think that's a great area of where startups are really helping out in terms of, first of all, being able to understand what OT is and, figure out, nobody has just Siemens or GE or ABB, everybody has a mashup of a bunch of these equipment. So somebody has to go in, figure out all the SCADA systems, all the different protocols, and eventually come up with the security policies. I guess the more important piece is the people who are going to solve this problem are people who understand the domain, because the least what you can do is by pinging, not bump the equipment up my network. There goes the entire piece of security, because I don't want to go again in IT versus OT, but the main differentiation for everyone is IT security, as you have it, is best effort basis, right? Or on the packets. I'm going to send you another packet, didn't reach you, I'm going to send you that one more time. Come to OT world, well, I sent you the packet, you better receive it, because I'm not going to send it to you again. That's a huge difference in how you operate security on those two different things. And that's where the startups are kind of really.
Yeah, I think since we're talking about startups and differentiation here, right, the importance of data, I think a lot of large companies have a lot of data, but there is a long tail of data which, if you can get access to, that's pretty unique. For example, as mentioned John here, they bought a company called Blue River,
Yes.
which was a company which was just spraying lettuce with pesticides, and I think they probably have the largest amount of lettuce data out there, right? I think so. A lot of startups can have access to very unique data. I think as we invest in companies in AI, the question we ask is the algorithms are to a certain extent a differentiation, but I think more it comes down to the data and how do you have not just access to data, but a continuous access to more and more data, and it's kind of like a positive flywheel, because the more data you have access to, your algorithms get much better, it gives you more competitive advantage, and then you can get access to more data.
That's a great argument, and the story which you already referred to, but incomplete, was the way these guys did that was actually they had 6 guys, just coming out of the college, 4th year, eventually go out with the digital camera in the fields of Idaho or wherever else, just clicking pictures of lettuce. That's it. At the end of the day, they came up with the data set, which was 675 pictures or so of lettuce. But that was 675 more than anybody else who had that. And they used that training algorithm to start with, created a data set, and eventually sold the company. So, please create your data set, huge $1 million opportunities right here.
Okay, so we're already starting to make a tag on the algorithms are higher value than the sensors, data sets potentially higher value than the algorithms.
I think it optically just it's controversial at all. I think data is more valuable than algorithms, because algorithms are, they're very important. It's a lot of R&D, billions of dollars, but it's been phenomenal that we're at a point in history where people are sharing their algorithms. So I think big companies and small and research universities are all putting out their, I wouldn't say latest research, but at least close to latest. And I think data gets a lot more value because algorithms people have access to it.
I think it's the data and how you integrate it into the workflow and how you deliver it in such a way that you instrument it to a way to gather additional data to get that virtuous cycle going that Vijay was referring to. I think that's what creates the value.
What do you think? Data or,
I think
data or algorithms?
I think data. I'm not. No, I gotta speak the truth. I think it's really data. And what I like about that is that it kind of completes the cycle of going back to the hardware and the basic sensing. It's about knowing where to put a sensor and also to collect the very best information you can.
Right.
And that's, not that we only do hardware investments, far from it, but I think we're moving back maybe, and maybe this is a bigger topic, but I think the venture community is moving back towards some excitement about hardware and about deep tech. So it's something we're excited about.
I guess, sorry, I was just saying, to complete, I think the domain expertise takes the cake for me to begin with. domain expertise can relate that data in a better way, especially if you're talking about big machines and doing anything with it. Then comes the data, and obviously algorithms and compute is unfortunately is going to be commoditized.
Yeah, I think opposite view on that. I don't think compute will get commoditized. I think it's
well, commoditized by only Intel will have access to it.
No, I think speaking of compute, I think what is interesting is it used to be that people used to build architectures and the software used to be developed on top of it. I think it's nice to see the switch right now where a lot of the software arguments are kind of driving the kinds of compute requirements. So it's kind of the hardware, software, now software is just driving the hardware back. And I think as long as a company, whether it's Intel or someone else, is agile enough to understand the shifts in the software paradigm, I think it will be, we can keep ourselves from commoditizing, right? And I think as long as there is a need for processing, and I don't see the need for compute going anywhere.
Gotcha. All right. So now time for the big questions. Where is the money? When is it going to kick in? As investors, which areas are exciting you the most for placing bets in the next 5 years?
Yeah, I can start. I think, the two areas, when I think about where the money is and where it's going to kick in, I think about where is the connectivity and where is the data readily available. So I think for me, one of those areas is sort of the physical security area where there's already a lot of cameras in place. I think that's an area where the data exists, the value is there, and it's people need to find out the right insertion method and the right way to deliver value to that ecosystem. I think that's one. One that, from a timing perspective, might be a little contrarian. I do think just the amount of dollars going into the autonomous vehicle space is going to drive that pretty quickly. It's a lot of constituents with a lot at stake and a lot of dollars being invested. I think that will happen faster than people think it will.
Just let me, what is Cisco's direct approach, as much as you're able to say, with autonomous vehicles?
So really, the way we think about that is it will be a important endpoint. So right now, one of the largest segments of connectivity that Jasper provides is to vehicles. So Tesla's, Ford's, GM's, companies, cars like that. As those connected vehicles change, the nature of the data coming out of those vehicles changes, the number of connected vehicles changes, and the data volume goes up. I think we want to be sort of front and center and understand how that affects our product and what we need to deliver. From a security perspective, from an analytics perspective, from a software delivery perspective, those different areas. So it's really context for us. We're not building a autonomous vehicle.
Nor is Siemens, but I was hearing before the panel that you guys are thinking heavily about transportation and autonomy.
We are.
That's obviously one of the big areas. Is that where you also would say money's going to be made?
Yes, I think so. I think I mentioned it before. Autonomous transportation to me is, right now, we're in this era, and I don't know how long it'll last, but it's a place where demand outstrips what the market is able to provide. And there's a technology requirement that companies can't hit yet. And to me, that's an incredibly exciting place. If you look at a lot of industrial IoT, we've had kind of the opposite situation where the technology arrived early, the markets haven't, and we're kind of waiting. If you think about fundamental startup advantage, it's speed. And I think this is a place where startups will be able to go faster than any of the traditional OEMs or tier 1s or tier 2s and be able to innovate. And also, it's a very traditional industry where you've had traditional kind of layered relationships that is totally being disrupted by new entrants like Tesla, like Uber and Lyft, and so forth. To me, that is fantastic. The disruption means that there will be a lot of questions about whether we survive or don't survive among the traditional players, and a lot of money will be thrown around to preserve position or improve position. So we like that space. And it's not just cars. I think Siemens is actually involved in autonomous flight as well, or at least electric flight, short haul type robo-taxis. We developed, for example, very high power to weight ratio electric motors. So we're in that area, and we have a deep penetration in rail as well. And I think a lot of these segments will get impacted by the autonomous future, as well as smart cities. So Siemens is a big infrastructure player. And one thing we don't talk about a lot is, for example, autonomous transportation and traffic management in dense urban areas, a lot is going to have to change on the infrastructure side. So that's one area that we're really excited about. But I also think, just in terms of broader spaces, I think I mentioned earlier, robotics is also a place in manufacturing, specifically where I think there's a lot of room for disruption and growth. And I see less need for evangelism there than I do in a lot of the other more traditional IoT spaces. An area that we haven't looked at a lot to date, but I think is interesting, is also digital health. I think there are big changes happening in healthcare, and I think that this is more of a consumer angle, but I think there will be increasing adoption of wearables and moving away from the traditional way that we manage our lives.
I'll take a different approach to it in terms of most of the IoT problems are you're grabbing the data, doing something, eventually getting it somewhere else. So I think the opportunities for startups are all across the process. One, obviously, as we talked about, whether it's autonomous car, whether it's digital health or demonstrating things, grabbing that data, cleaning it, tagging it, mapping it, getting it ready for any such model, I think that is an opportunity. Get that over to, analyze it at the edge using the best possible compute, best possible algorithms, best possible domain expertise, that's another opportunity. Getting that thing over back to the cloud so that you can actually, come up with the entire digital twin philosophy, which is grabbing all that assets throughout the world and getting the best information from all. So if you can do eventually there are multiple different people, no one company is going to do all of these things, but there are different opportunities within that. If you can do one thing and only one thing better, I think that's a great opportunity for you guys to do. There are a lot of companies which we have funded, the one which I keep talking about, like the tagging piece, Element Analytics, very recently, company which Hive created, Foghorn Edge Analytics, another one, and then companies which are building the digital twin model. The problem is going to, irrespective of what the asset is, the problem remains the same. The better you can come up with a way to come up to talk to Siemens or Cisco or Intel or GE and say, here's how I'm going to solve or improve the outcome for your customer by 1% to whatever, choose your percentage. That gets people paying attention to you. It doesn't matter what size of a startup, right? And Ravi knows this very well. Foghorn was 2 guys and actually no. So it was just 2 guys, okay. So, and from that to a very successful company. That's where the opportunity is.
I think from an Intel standpoint, I would say, even from an industry standpoint, I think computer vision is probably the biggest area we've seen like an advances in. I would argue you wouldn't have had autonomous vehicles or even satellite imagery without computer vision. I think that's even robotics for that matter. I mean, computer vision is a fundamental capability which has changed in the last 1 year, which has driven new industries, new growth areas. So that's the fastest growing category business for our surveillance business at Intel as well. The second is autonomous systems, and I say systems very broadly. We bought Mobileye on the driving side. We acquired quite a few companies, including Nirvana and others, mostly to build the autonomous stack. And the question becomes, cars are great, but where do you go next, right? I think as Debjit said, eVTOLs and aviation, and then there's no reason for the ships not to be autonomous. Same thing with last mile delivery. If you look at a robot, it's almost like an autonomous vehicle, right? You have LiDAR, you have computer vision, you have a lot of processing to understand what needs to be done. I think autonomous systems overall, I think is a great place for us to look at. Personal investment standpoint, I really like what happens beyond deep learning, which is once you have the data, how do you make interpretations out of that, and like parallels of cognition, and there's different kinds of AI. Very interesting.
I think it's also a foregone conclusion that you're going to have industrial robots moving around, doing short cycle machine learning applications, and see a blurring line between some of the same stuff that we're seeing on the drone side, seeping over into the traditional robotic side. So it's a pretty exciting time. I do wonder though, because so many companies have come to us and pitched that traditional industrial IoT,
Yeah.
to your point, collect all the data from the machine, get it off the motor, make sense of it, tell them when it's going to fail. There have been like so many of these companies that kind of pitched us. And I think I can also count on one hand the number of really big industrial IoT companies that have gotten a lot of velocity, and there's really not any exits at all. So, what's the biggest learning there? You know, why have these not succeeded, and why is it going to be different? We touched on it a little bit. Why is this going to be different with vehicles, other than the OEMs were so slow, the starts were so fast, and there's going to be consolidation? Why was that not the case on the industrial IoT side?
I don't know anything about autonomous vehicles, but what I can tell you, we passed on a lot of companies which were raising, which were talking about predictive maintenance, to your point. I think there were two kinds of companies which we saw about 12 to 18 months ago. One were, hey, we are the great toolkit, machine learning toolkit. Give me the kind of any data, I'm going to make sense of it, and I'm going to be great at it. And then there was the other companies which were like, okay, I know the transportation business for past 20 years. I don't know anything else. I'm trying to now use machine learning to it, and maybe I'm going to improve this. Are you impressed? And guess what? We were more impressed with the second one, and we saw a bunch of, unfortunately, not so great exits on the former ones because the algorithms could not take you so far. So predictive maintenance was just first piece of it. Everybody now has predictive maintenance. So the question is, well, now what? How do you then use that information, make sense of it, and tell me what the actual process which you're trying to try. That's where the differentiation is. So if you're thinking about any of your any machine learning companies, I would encourage you not to go with the generic toolkits. Please use whatever the domain expertise you guys have, and bring that to fore. That is a great differentiator.
I think it's like place in that, which is exactly I think what you're talking about it. When we hear toolkits, I think it's not impressive what kind of plugins you're using. I think the first thing we really want to know is what is the application of that particular technology. What does it improve the top line, reduce the bottom line? Where is the actual application? And then we can talk through how is it different than somebody else's. But I think the ROI for application of AI is probably more important than the kind of AI you use. So I think any VC, financial VC, would easily sift through all the jargon and get to the point where we actually see an application instead of just the technology.
So just on that's a very important point.
Yes, and I would agree. Double underscore. Go on neural nets, CNN, blockchain.
Yeah.
I mean,
You start
doesn't
to
matter. Is the juice worth the squeeze? Is it worth putting in all this equipment, collecting data? What problem are you trying to solve? Where is the ROI for the customer? And it's amazing how many startups that come to us can ask, can't answer that very fundamental question.
And I think that
How do you create feedback loop and drive value to it?
exactly. And I think the important piece, the very important piece which I just mentioned is the ROI of AI. Well, guess what? Right now, and this is the challenge which we talk about where I see the most opportunity right now for startups. I think that's where it is. Because guess what? Most of the AI systems which are put in production, irrespective of consumer, industrial, whatever it is, they had some research data, they had got some data, they are now putting in through initial level of the production. Think about the software life cycle, which we all know here in the Valley. Once you put a software in production, the cost of supporting a software in production versus cost of supporting AI in production. Nobody's really thinking about the cost of supporting AI in production. That is a very troubling thought in our world because the models might change, the temperature change, the humidity change, blah, 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 change my entire model. Who's going to support that again? And if you are not thinking about the entire software life cycle kind of way, the AI life cycle is where a lot of money is to be made. And that's where I think if you think about creating opportunities, think about how will you take the AI to production. And I guess in very early days, nobody else is doing it. So I'm just very passionate about this specific topic.
I think Bonsai is getting it.
Yes.
Trying to democratize AI and unpack the complexity of black box solutions. Just so happens it seems today we are investors.
Yes.
Thank you.
I can say Bonsai. Yes. Bonsai is another company which
I can plug a few of my startups here.
Yes.
Although just so you know, the average acquisition price of an AI engineer is like $5 million. So even if you don't make money, even if you don't make money on the ROI side, it's a good acquisition opportunity in the short term.
Or at least change all the job titles of your employees to
AI engineer.
AI engineer. I think probably we're running out of time here, so we'll probably move over to the Q&A. Any more thoughts on the industrial IoT dilemma and why there haven't been these huge pops in value and exits?
Maybe very quickly, to me it's heterogeneity. So it's lack of clear focus, it's many different types of customers, and a lot of IoT companies have tried to build product and failed. They've ended up going into the bespoke implementation and services game, which is simply not scalable.
So what's your take on uptake, having raised money now at a $2 billion post? And they're, in theory, IoT, AI, mashed up.
And I think C3 is in the same.
C3 IoT, I mean,
same
I don't know what the hell Tom was building. I still don't really know what's behind it.
I think if you break it down, there's a lot of services revenue in there.
Oh, that's
Consulting and services. And I think that is not really kind of a scalable venture type business for the most part.
It's a sharpened, honed, consultative approach to
Yeah.
pulling in data, doing what we're trying to have not be done with element analytics.
Yes.
Yeah, that's a lot more to take than AI.
Okay. And that one, I just don't know. I mean, it's just, the number is eye-popping.
I can't talk about it.
Okay. A lot of mystique. So it sounds like, some of the takeaways, domain expertise does matter. Not coming in with generic AI models, getting past the jargon to really figure out what the value proposition is and the ROI for the end user. And also having some sort of unfair advantage to get access to a proprietary data set that you can lock in and create a bit of a flywheel is a pretty necessary component. So enjoyed the conversation. With that, looks like we're ready to transition. We have
Let's go to the
some questions
audience.
from the
They've been
crowd.
patient. So just raise your hands.
Hi, something here. I had a question around, because I think we are anywhere in the conversation that you guys were talking about. There's different components of AI, but there's also this whole, in order for anything, any kind of innovation in the IoT space, for it to be successful, there is an ecosystem play that is much necessary. And we tried to at CISCO, there's a lot of investment that needs to happen in the ecosystem solution development in order for you to really get to the ROI issue. So my question really is around how are maybe you or what's really happening around building out those ecosystems or platforms in order for real deployment of IoT, whether it's in smart cities, transportation, some of the industrial ecosystems. I didn't hear that conversation around this.
Yeah, that's called gene critics or CNS Mindspring. That is the ecosystem. Come develop with us. Sorry.
That's exactly what I was going to say.
I think from an infrastructure standpoint, I think AI is still not there yet. I mean, we saw the big data come in, the whole infrastructure happen, and I think that's a predecessor for this whole AI thing because we have more data. But I haven't seen as many infrastructure companies come out at scale with AI as part of the big data space, and dollars. That's I would call it as the infrastructure as well. So it's happening, but it's going a little bit slower. But the big infrastructures have been TensorFlow, like the Amazons and the Microsofts of the world, which have taken the place of what used to be the infrastructure of the past. So that you're seeing that as well. So.
I think Debjit said it earlier, there's just a lot of heterogeneity around the ecosystem. So I think for a startup to break through, they're going to have to pick something that doesn't require everything, solve a really specific use case, get scale there, and then maybe from there they can branch out. But I think waiting for all the rest of the stuff to bubble up is you're going to be waiting for a long time.
But I think, going to Abhishek's point, I think you actually hit upon one of the main kind of value propositions of platforms like Maestro or Predix and why we came up with them in the first place. I think we can serve kind of that hub or nuclei function for a lot of startups to build really, really nice satellite technologies all around it and coming together to build the solution that you need.
Yeah,
And I follow on that. Would say you're going to see more of this interconnectivity between the platforms. We know full well that there is no factory that's 100% Siemens, nor is there one that's 100% ABB or Rockwell. There is a lot of, say, heterogeneity. So you're going to have connectivity between the devices, both on-prem, but also have to have intra-cloud connectivity. So the original thesis of having a one-size-fits-all, all your data is going to go to one cloud, which was the industrial IoT message with one company pushing it in particular about 3-4 years ago, I think it's playing out to not be the case. And we're all getting a lot smarter about how we need to have hybrids and work nicely. So you're going to see a lot more of that Switzerland mentality, I think.
Question?
I guess I can go back to the problem of heterogeneous devices. I spend a lot of time trying to automate my home, and the biggest chunk of my time was getting different devices to talk to each other. But stepping one level higher than that, if we go back to the day of Edison, imagine if the consumer had to actually go buy the wires and actually go wire his house to make sure that everything works together. Are we facing a problem of a similar nature? And if we are, then there's another problem, and that is the consumer can go to Best Buy or whatever. I'm thinking here on the information space to go and buy a coherent system that will actually work. I mean, Nest is great, but it just does one tiny thing, tiny use case.
Yeah, but I would ask, where is Nest connecting with the other devices? How is my Nest talking to the Nest, other Nest devices in my house or to my garage door opener? It's not through the wires. It's all happening in the cloud, and that's a lot of technology that we're deploying in our IoT ecosystem to have that inter-cloud connectivity. So that if you want to throw data into MindSphere or have something in Predix, but you also have a slew of motors or robots that are throwing up data to ABB ability, they can actually work. And digital twins may not be completely transferable, and you have different ways of dealing with predictive maintenance, but the data set is not going to be captive within one system.
I think a lot of standardization has already happened. If you think about how you do the API calls, whatever MQTT, or what kind of connectivity or what kind of backhaul you have, all of that is done. The reason why MindSphere or EDBs or G Predix are a little bit important is because if you are an application developer, you want to develop application. You don't want to take care of the infrastructure, like you said, or the connectivity and everything else. Well, let Microsoft Azure take care of the cloud piece for you. Let Predix or MindSphere take care of how do I talk to this particular equipment or get the data from it. You just develop the application, and I think that's what would be important as we move forward. And it's not going to be like Grant said. It's not going to be one company which will take the cake here. It's going to be just like a normal factory. There is not only GE or Siemens or ABB. It's going to be a combination.
Yeah, I think it's more considered. The question is like who's making the money in cloud? Right? So for example, Cortana can talk to Siri and data can go to each of the cloud providers, but they'll pretty much make sure everyone talks to everything. I've seen that happening as well. Same thing with Mesh, right? The value of the data, not just the hard to make money in the hardware, sure. But, and then you have opportunities where companies can come in and try to abstract their communication itself, like IoT or others. So it will happen as long as it's like a living opportunity.
Do you guys see an abstracted kind of rules engine like IFT appearing for more industrial applications, or do you see that being relevant for industrial apps?
We have looked at a couple of companies in that domain and came very close to investing in one. But it's not only the application but the entire process. How can you get that process going for that? And I think that is going to become very important because there's disparate kind of data sets emerging from all different things, eventually trying to create a business process to give you some outcome. And the easier it is for people to do that, the better the adoption will be of a platform versus the other.
Outcomes matter. Anyone else?
Yeah.
You don't get to ask the question.
I was talking to Rod Woodward yesterday. So, generally just about the height. And so one of the slides you put there, and I just want to talk about it, right? High marginal cost leads to slow deployment. It talks about like many cars that are delivered today will still be on the road in 2040. All the houses still will be there 100 plus years, and most of the systems in US will be still running Windows 3 or are booted by 18-inch floppy drive. Right? So that means that like, a lot of these systems that are there that are working just fine. We talk about AI, we talk about everything as if it's there. Right? It's hard. Like we really the temperature of the Raspberry Pi that people talk about. Those are just very Mickey Mouse topics. Right? The real problems are very hard. So we tend to overestimate like the effect of technology, like in short run.
But we underestimate the long term. So to me, it sounds like Rodney's coming over with excuses why we think hasn't been doing better than it has.
Yeah. I mean, Rodney is a different company, right? Baxter.
Yeah,
so,
robots is one of those exact places where even though you're not going to strip out an A-to-B robot,
yeah.
you can layer on intelligence and AI, just like with biorobotics, to make them intelligent, connected things. I think that's the entire premise of where IoT melding with AI can be transformative for industrial objects.
Yeah, so the question is, are we there? Right? Because we talk as if we are there, but I don't think so. Like, I don't see any real production deployment yet. Like, really letting robotics brand, right? But AI and IoT, it's so hard to take a CNN. Like, even though Jan LeCun says everything's CNN, but take it and run it on a small piece of hardware consistently, it's hard. So my question to the panel is, are we there? Is there a real production thing that's out there, or do we really
It's a valid question. I mean, that's the inflection point.
Yeah, I think.
Are we?
I guess there's two different questions there. I think one is, on the long term, yes, we agree that AI has benefit, but in the short term, I think the hype has gone much higher than the actual value. So I don't think so I think there'll be a correction in terms of what we call AI and what the valuations are going to be. But in the long term, I think we all agree that there is real benefit to that, right? I mean, whether you take a camera and even autonomous driving, there's CNNs are driving a lot of the vision applications there. So I think we're in the short term.
Yeah, I think we get there by parts. I think it is happening on the edge already, right? Because I think sensors require those types of algorithms and AI on the edge to boil the data down to what's essential. But I think seeing it at a more macro level is going to take some time because of the heterogeneity. I also think you will start to see at the application layer might even be one of the first places you'll see it. It's going to maybe be at the barbells, right? You're going to see it in the endpoints, and maybe at the application layer, but not necessarily in between for some period of time.
An example is medical imaging, right? I mean, we're seeing people can detect images better than humans. I think those are all applications where you can actually see the cancer in shot.
We have real deployments. We have fleet operations, former investors have been using AI for 6 years. So there's more and more of these cases. It is tougher, I think, for industrial people to stomach, because as soon as you have an intelligent agent making a decision and saying reducing the level of some piece of equipment because it detected overheating, but they don't know why the level's going down, that's going to freak a lot of people out. And if these are black box AI agents, that's even worse. So there's a lot of issues that can be worked with. It's just a kind of workflow perspective.
Let's take two
But
more
it's
questions.
a very valid question.
Hi, Sunday Shmuley, a great panel. Question for you. We are, at my company, we're thinking through monetization strategies for industrial IoT, and quite frankly, we're struggling. As you think about really turning IoT into the next generation of billion-dollar businesses for your companies, how do you really think about the monetization models of moving beyond
I can take this. So we are already doing some of this. We are going with what we call gain share models to our customers. Essentially, guaranteeing an outcome. Think about a windmill operator. They are not really in the renewable utility. They're not in the business of windmill operation, but generating electricity out of it. So you go in and say, I'm going to reduce your operating cost of those windmills by 2% or 3%. And if I do, then I'm going to take a share off. How do I do that? How do I do the magic? It doesn't matter. I'm going to get something called as industrial IoT system. I'll put it there and get the data, analyze all of that for you, and the magic will appear. And then that's something which we are already doing. And I think as you think more and more towards it, that's where the business outcomes are going to drive. So industrial IoT is a ways and means to get there. It's going to be the business outcomes which will create these opportunities for people.
That's why you have to get past the sensorization for the sake of having more data to really drive that use case and the value for the customer. And it's been the fundamental flaw with a lot of these IoT companies. It's just
over-sensorization.
It's just more telemetry. Like, great. Again, what does that can actually do for me? So what you have to identify with your customer is it can increase quality, throughput, reduce downtime, whatever that is, and then work back in the math to figure out how you charge for it.
Value-based pricing. I mean, at the end of it, all comes down to that, whether you're talking about per bit transferred, per device, some flat subscription fee. At the end of the day, it all comes down to value-based pricing.
Actually, that was pretty much my questions. I actually lived through that. I developed a system without AI doing failure prediction for Palo 26 years ago. The business model failed. My investor said the same thing. He could predict railway accidents. Nobody wanted to pay, which comes back to the great question of this lady over here about ecosystems. So from an investor perspective, you want to understand how you charge simply. Right? If I have a gadget, I can sell you a gadget. It's very straightforward. Now, I also know for a fact, since I've been through this process 6 years ago, that if you want to predict, you need a very long database. It takes you literally at least 6 months to collect data to have any reasonable outcome. That's at least NASA told me that and advised me on this. How do you survive as a startup when you really don't have the quality of data and the business model hasn't been really proven? Because I can tell anyone, we're going to fail. They don't believe you. The second one is the ecosystem. Even if they should assume that the failure will happen, they might not actually buy it because they're not personally responsible for that failure. They turn a blind eye. This actually happens. So how do you reconcile the politics of who's carrying what cost and what risk? Everybody wants to push the money to someone else. So how do you come across that?
And I would say this is really a specific question to APMs, Asset Performance Management, understanding assets.
Right.
There's a whole host of other monetization models around improvements beyond just predicting failure and understanding the asset. And there's also the question of, are you going to use a physics model? Because we actually know our assets. I don't need the 6 months of data. I actually know when my stuff's going to fail based upon the physics, not just the statistics. But within that APM, I would say, you guys are pretty good at this.
Yeah.
And then how do you, through the GE break this service model, move this kind of agent issue?
Yeah. So we as a startup, you come to the Predix platform with your application. You have access to all sorts of data through API calls. Weather data, this kind of heat pump data, turbine data, obviously not in current production, but good enough for you to get started and prove what you're bringing to the table. And then to the second question which you asked, which is a great one, but in a generic sense, I'll answer it, is basically whose problem is it? And I think the question you ask is, if this thing, whatever you're building, that application, that asset which is connected to it goes down, who gets the first call? Is it GE? Is it you? Because that determines where the ownership lies. And if it is you, then you better be very good at it before it comes to GE. Because if it's going to be GE, I'm not going to let you do it in a production environment unless and absolutely I'm certain that you will not bring it down in an industrial one. So.
Yeah, I think the other point is, as big companies, right, I think there's a responsibility for companies to put out data sets there. I mean, a lot of big CSPs are doing that. I think if companies want to drive innovation in their equipment or in their kind of capabilities, they should put out the data sets so people can train and be better suited to like service that kind of industry. So I think there's a responsibility from all of the Fortune 1,500 companies to put out this product. And we haven't seen as many as there should be.
And then we get it. Again, this is an ecosystem problem. We are trying to help the startup ecosystem. Obviously, we are not as fast as some of the other companies, as you would imagine. But, we, Siemens, ABB, everybody's pitching hard to say, okay, I'm going to make your life as easy as we can, given that you're still dealing with deterministic in life or death situations, develop your own application. Unlike me trying to sell you a shoe on a Zappos.com, unfortunately, there are much bigger consequences here. So with those things underlying, that's the best we can do. It's a process, it's an odyssey,
And it's a problem. For instance, our robots have never sold through integrators. So what do you do when they're that removed from the customer? Or if they're using a piece of software from Aveo and someone gets waxed?
Yeah.
Whose issue is this? So it's a thorny issue, but I guess one we're not going to resolve tonight. Okay.
And so I want to thank all of you, especially Grant, for doing such an awesome job of moderating. What do you guys?
Yes. Also.